Hey guys, what's up? Welcome to another video of CHE 101, and today we will be talking about the manometer and how to get pressure readings. So this is a topic in momentum transfer or MOMECHE and also a topic in basic CHE calculations or chen.acads. So let's begin. So there's only one equation or formula to be remembered, which is the rho GH. But to explain it in more detail, there's a difference between getting the pressure for liquids and gases. So for liquids, the specific gravity is measured with reference to the density of water, while for gases, it's measured with reference to the density of air. Okay, so that's just the difference. Then some important concepts that I always remember personally. So pressure increases when you go down and pressure decreases when you go up. And then pressure at two different points belonging to the same fluid section at the same heights are equal. So to show you a more visual representation of the concepts, let's take a look at this diagram. So concept number one, let's focus on the points D, C, and B at this column of fluid. So with respect to point C, when you go down, pressure increases. So pressure at point B is greater than the pressure at point C. While when you go up, it decreases. So pressure at point D is less than the pressure at point C. And then second concept, pressure at two different points at the same fluid section and at the same height are equal. So let's focus first on points A, C, and E. So points A and C, they belong to the same fluid section, this blue fluid, and then they're at the same height. So we can say that the pressure at point A is equal to the pressure at point C. Okay, but how about points C and E? They're both at the same height. They both belong to the same fluid, but they don't belong to the same section. When you look at the figure, this blue fluid section at the left and this blue fluid section at the right, they're separated by this green fluid section. So we cannot consider them at the same fluid section. Therefore, the pressure at point C is not equal to the pressure at point E. Okay? And then, how about points C and B? They belong to the same fluid section, this blue fluid section at the left, but they're not at the same height. So we cannot say that pressure at point C is equal to the pressure at point B. And it was also given earlier that the pressure at point B is greater than the pressure at point C. Okay, so that's all for the concept. So let's now proceed to solving problems. Okay, so problems here are taken from the book Fluid Mechanics for Rajasthan Technical University by Purohit K, Harsha SV, and Purohit RK. Right, so we have this figure and then we have the following heights given, and then the pressure at point B is 1 bar. So we are to find the pressure at point A. Okay, so how do we do this? Okay, so for the computation, we will be using pressure in pascals, the density or the rho in kilograms per meter cube, the gravity as 9.8 newtons per kilogram, and then the height in meters, so that we are consistent with the units, right? So we are given the measurement of the heights, the pressure at point B, and the specific gravities of the fluids. What we need to find, or the required quantity here, is the pressure at point A. So how do we do this? We first write a pressure balance between points B and A. So we begin with pressure at point B. So from point B, so that's P sub B, okay, uh, we can go up and then down. But let's use the concept number two. So we don't need to actually go up all the way here and then go down here. We can actually take the pressure instantly at along this point, okay, along this height, so that we don't make the solution too long. So we can say that we will take the pressure at this height. So this height is equal to h5. Okay, this height minus this height, which is H4 plus H3. So this height here is H5 minus the quantity H4 plus H3. So we're going up, so we need to subtract. So that's minus the specific gravity of water, the density of water, the gravity, and then the height, this one, H5 minus H4 plus H3. Okay. So after getting the pressure at this height, it's the same it's the same as the pressure at this point. Okay. So basically we just kind of took a shortcut up to this point. So now we're here, and then again we don't need to go down here and then go up again. We can since they're the same fluid, okay, we can say that the pressure at this point is equal to the pressure at this point. So now we're here, okay, and then we need now to go up. So we're going to get the pressure at this point. So that's since we're going up again, that's minus. This time we're at this fluid, the mercury. So Sg of mercury, then density of water, gravity, and then height H3. Okay. Then finally we're here, and then we need to go to point A. Then since it's just the same fluid, we can say that this entire height, okay, so we need the pressure here, which is the same at this height. So we can get the pressure of carbon tetrachloride at this entire height, which is H1 plus H2. So again, since we're going up, okay, so just to show the path that we took, so we went up a while ago, we went right here, since it's the same pressure point. Same with here, we go to the right, okay, and then now we're here, we go up, then finally we go up. So that's the path that we took. Anyway, going back, we're at this point, we're going up, so that's minus again. This time the specific gravity of carbon tetrachloride. Okay, then the density of water, then gravity, then the entire height, H2 plus H1, and that is equal to the pressure at point A, P sub A. Okay, so we solve this in another slide. So here's the equation. Then we just substitute the values. P sub B is 1 bar or 100,000 pascals. I won't write the units anymore to kind of save space. Okay, but just remember, be consistent when you're using the units. Okay, then specific gravity of water is 1.0. Density of water is 1,000 kilograms per cubic meter. Gravity is 9.8 newtons per kilogram. Okay, then the height is, okay, going back, H5 is 1 meter, H4 is 0.3 meters, H3 is 0.5 meters. Okay, so that's 1 minus 0.3 plus 0.5. Okay, then specific gravity of mercury is 13.6. Okay, then 1,000 again, then 9,800, then height H3, which is 0.5 meters. Okay, then finally, Sg of carbon tetrachloride is 1.6 here. Density of water is 1,000. Okay, gravity again is 9.8. Then the total height H2 plus H1 is 1 meter plus 0.7 meters. 1 plus 0.7 equals the pressure at point A. And then simplifying, you should get P sub A equal to 4,744 pascals. And that's the pressure at point A. We move to the next problem. So here we have two manometers that are interconnected. So one is inverted and one's upright. And then we are given this diagram, and then along with it are the specific gravities of the different fluids present. So for convenience, we have two oils here. we will name this one as oil 1, this one as oil 2. Okay, so that we don't get confused in the solution. And then we have here measurements for A, B, and H sub 1, and we are to find H sub 2. Okay, so how do we do this? This seems kind of complicated, right? So, okay, we are only given the heights. We need this missing height. We have the specific gravities. But what makes it difficult is that we don't have exact measurements for the pressures at points A and B. So how do we do it? We can write a pressure balance between points A and B using number 1, the top half. So we will name this the top balance or top pressure balance. Okay, let's do that first. And then we will also do the bottom pressure balance. Okay, or simply the bottom balance. Right? So from the using the top balance, let's start at point A. Okay, the pressure at point A here. So we go to the pressure at this point. So we go up. So that's going to be, oops, sorry. So that's going to be P sub A minus the specific gravity of this fluid, which is water. Okay. Then again, density of water, gravity, then the height, which is this one, the A. Okay. Then from here, using concept number 2, we just need to solve the pressure at this point, which will be equal to the pressure at this point. So we're going up again. Then the pressure at this point from this point will be equal to minus the specific gravity of the new fluid, which is oil 1. So that's specific gravity of oil 1, density of water, gravity, then height, which is H1. And then, pressures at these 2 points are equal using concept 2. Then finally, at this point, we're going down to get the pressure at this point, which is the same as the pressure at point B. So we're going down. Okay, so since we're going down, that's now positive or addition. So that's plus specific gravity now of oil 2. Okay, then density of water, gravity, and then the total height, which is this one. So that's H1 plus A. So H1 plus A equal to pressure at point B. So this will be our first equation. Then the second one, we use the bottom half. So from point A, we go down. Okay, we go down to this point. And then using the concepts, again, it's equal to the pressure at this point. Then now along this fluid, we go up. Okay, so we take the pressure at this point, and then finally we take the we go up again to get the pressure at this point, okay, which is equal to the pressure at point B. So go up at this height, which is if we look at the figure, the entire height is B. Okay, this entire thing is B. This part is H2. So this height should be B minus H2. So we write the pressure balance. From point A, we go down. So that's plus specific gravity of water, density of water, gravity, and then the height B. Okay. Then at this point, it's equal to this point. So now we go up. So minus specific gravity of the manometer fluid. Let's name that as M fluid. Density of water, gravity, and then the height, H2. And then finally, we're going up again. So that's minus again, Sg of oil 2, density of water, G. But this time, the height is again B minus H2. Equal to pressure at point B. So now we have two equations, and you might wonder how can we solve for H2 given that we have three unknown variables. So that's P sub A, P sub B, and H sub 2. But we only have two equations. So we can manipulate these equations to form to form equations that are equivalent in terms of P sub A and P sub B. So let's first simplify the equations to show you how we will further solve the problem. So P sub A minus 1.0 specific gravity of water, then density is 1000, gravity is 9.8, then A is equal to 0.2 meters. Okay, then minus specific gravity of oil 1, that's 0.7, then 1000 again, then 9.8, then the height H1, which is 1.2 meters. Then specific gravity of oil 2, that's 0.8. Okay, then 1000 again, 9.8 again. Then we have H1, which is 1.2, plus H2, which, or A rather, not H2, which is 0.2, equal to pressure at point B. So when we simplify this, we should get P sub A plus 784 pascals equals P sub B. So this will be our first equation. Next, we simplify the bottom balance. So that's P sub A plus 1.0, 1000, 9.8. Then B is 1 meter. And then minus specific gravity of the manometer fluid, that's 2.94. Then 1000 again, density of water, gravity is 9.8. Then the unknown H2 minus specific gravity of oil 2, that's 0.8. Density of water 1000, gravity 9.8. And then B, which is 1, okay, then minus H2 equals pressure at point B. Then simplifying this equation, you should get P sub A plus 1960 minus 20,972 H2 equals pressure at point B. So that will be our second equation. So using 1 and 2, let me just change it. All right. Using equations 1 and 2, we have this one and this one. H2 equals PB. So this is 1, this is 2. So if you notice, you can actually subtract the two equations. So that cancels out the PA. Subtract. That cancels the P sub A and the P sub B. So we're left with, okay, 784 minus 1960 minus 20,972 H2 equal to 0. And then solving for H2, we should get 0.056 meters or 56 millimeters. And that's now our answer for H sub 2. So in this video, we learned the important concepts and the basic formulas to be used when solving manometer problems and how to get or how to write pressure balances at different points. So hope you guys have learned something today. Thank you.